Math 1332, Chapter 2, Set Theory, Section 4, Using Sets to Solve Problems. Video 3, an example involving 3 sets. Now, your jaw might already be on the floor from the size of this word problem, but we're going to get through it bit by bit and draw a picture that's going to answer all of our questions. All right, let's get through it. A criminal justice major is studying the frequency of certain types of crimes in a nearby county. Interesting, but totally irrelevant to our problem. He studies the arrest records of 300 inmates at the county jail. They're telling us our universal set. And as you're reading a problem like this, it might not be a bad idea to highlight certain things and make note of what that represents. In this case, the cardinality of the universe is 300. Now, I'm not going to write all these on this page. I've already got them set up on the next page. But you should be thinking, what set are they describing? All right, so our universal set is going to be the 300 inmates at the county jail. And specifically asking about drug-related offenses, domestic violence, and theft of some sort. He finds that, all right, here comes the deluge of numbers. 194 had been arrested for theft. Now notice it didn't say theft only. So they may have been arrested for other things as well. 210 for drug offenses. And again, notice it doesn't say drug offenses only. So those 210 could have also been arrested for theft. And 170 for domestic violence. Again, the lack of the word only means that those 170 could have also been arrested for other things. Speaking of which, 142 had arrests for both theft and drugs. Now, that does not mention anything about domestic violence, so they may or may not have been arrested for domestic violence as well. Running out of colors here. 111 for both drugs and domestic violence, giving us a lot of numbers here. 91 for both theft and domestic violence, and we're still not out of numbers. We're almost out of colors. 45 have been arrested for all 3. All right, so there's the ones that have been arrested for everything. Draw a Venn diagram to represent these results and find the number of inmates that have been arrested for A, only drug-related offenses, B, thefts and domestic violence, but not drugs, C, theft or drugs, and D, none of these offenses. Is there a way to do this problem without a picture? Actually, yes. There's a whole slew of formulas that will represent how to connect the given information to the information that we want, coupled with a little bit of what's called linear algebra. But the good news is we don't need all that. What we need is a good picture and understand what it represents. Now, before we go to the next page and jump into the picture, let's go ahead and define a few sets. I've kind of implicitly defined the universal set already, but let's explicitly say that is the set of inmates. We can write this. This is going to be all words. That our universal set is the set of inmates. We could be more specific, the set of inmates whose arrest records were studied, but we'll just say it's the set of inmates. And since we're talking about those who've been arrested for theft, we'll say T is the set who were arrested for theft. Now, the problem with drug offenses and domestic violence is that they both start with D. So we'll use DR be the set who were arrested for drug offenses. And we'll say DV is the set who were arrested for domestic violence, of course, violence, violence. There we go. All right, so let's go ahead and define those sets here. And before we start talking about what cardinalities all the numbers represent, let me show you what I have on the next page. If you'll notice on the next page, I've already got a Venn diagram drawn with 3 circles, one for theft, one for drug offenses, and one for domestic violence. Also, notice that I've got all the numbers from the problem already extracted, and I'm using the set names instead of the actual words for brevity. So 300 inmates, 194 arrested for T, 210 arrested for drugs, 170 arrested for DV, 142, arrested for both theft and drug offenses, 111 arrested for both drug offenses and domestic violence, 91 arrested for both theft and domestic violence, and 45 arrested for all three, as well as the questions being asked. How many were arrested for only drug offenses, for theft and domestic violence, but not drug offenses, for theft or drug offenses, or none of these offenses? Now, how are we going to answer these? The same way we did with the two set problems. Fill in all the numbers in the Venn diagram and then use it to answer the questions. But the trick to filling in the numbers in the Venn diagram is to figure out which numbers represent which regions and where to start with. I'm going to go back into, first off, let me shrink this a little bit. I want to go in here so I can type something, but I also want to be able to see the Venn diagram. Next to each of these numbers, I'm going to write the regions that are represented. Now, the universe is going to be all of them, so there's no need to enumerate them. All 8 regions' cardinalities have to add up to 300. 194 arrested for theft. Which regions make up the theft circle? Regions 1, 2, 4, and 5. Make sure you understand that before we move on. The theft circle is comprised of regions 1, 2, 4, and 5. Which regions make up the drug offense circle? And I realized that my 3 got decapitated somehow. 1 second, folks. Not sure why it ended up over there, but we'll fix that. All right. I know what happened. All right, so 210 were arrested for drug offenses. So which regions comprise the drug offense circle? Oops, not what I wanted. Regions 2, 3, 5, and 6. 2, 3, 5, and 6. Okay. Which regions represent the domestic violence circle? Regions 4, 5, 6, and 7. 4, 5, 6, and 7. What about the 142 who were arrested for both theft and drug offenses? Theft and drug offenses. Well, and means intersection, right? So which regions represent the intersection of the T circle and the DR circle? If you said 2 and 5, you were correct. Now, if you said only 2, because it didn't say anything about domestic violence, well, it didn't. Maybe they didn't, or maybe they did. But if you're still not sure why T and why theft and drugs is regions 2 and 5, since it's not mentioning domestic violence, let's remove the domestic violence circle just for a moment. Which regions represent the intersection of the ones arrested for theft and the ones arrested for drug offenses? That football in the middle, which is made up of regions 2 and 5. All right, so 2 and 5. So I can't put the 142 yet because it needs to be split amongst those 2 regions, nor can I put any of the other numbers yet because none of them represent a single region. What about the 111 arrested for drug offenses and domestic violence? Which regions represent the overlap of the drug circle and the domestic violence circle? The answer is regions 5 and 6. Can't see it? How about now? Now, can you see why it's 5 and 6, the overlap of those 2 circles? 91 arrested for both theft and domestic violence. Which regions are the overlap of the T circle and the DV circle? Regions 4 and 5. Again, so far, every number that I've been given has represented more than one region. So I can't put any of those numbers in yet. What about the 45? 45 were arrested for all three. Which region represents, well, which region belongs to all three circles at the same time? There's only one region that does that. It's region 5. Now, do you have to list all these region numbers? No, but I did it to make a point. I can't put a number in the Venn diagram representing the cardinality of a region if it represents more than one region and I don't know anything else. There's only one number we were given that represents a single region, and it was the very last one. Let me give you a trick for dropping in for using these numbers. Go from the bottom up, because the majority of the time, the last number that you're given, not always, but the majority of the time, the last number that you're given represents a single region, and that's your starting point. So we're going to list which regions we fill in the order that we fill them in. Region 5 was pretty much given. There was nothing to calculate. We're going to start writing in this color of blue. Since region 5 represents the ones that were arrested for all three, there are 45 inmates in that middle region. Now, where do we go next? Well, here's a little trick, and here's an advantage to writing all these region numbers. Once you know a region's value, cross it out, not just where you originally did, but everywhere else it's listed. What's the advantage to that? Well, 3 of these numbers involve only a single region that we don't know at this point. For example, if we keep moving upward, this 91 represents regions 4 and 5, but we already know region 5. So now we can just do a subtraction problem. For region 4, because of that highlighted part, we know regions 4 and 5 add up to 91. So if we do 91 minus what's in region 5, because we already know it's 45, that difference is 46, which means in region 4, there are 46 inmates. And if we check and add those two regions, we do get 91. That's the overlap of the T and DV circles, and that's what it was supposed to be. All right. Oops. Let's cross out, now that we know region 4, let's cross out everywhere there's a region 4 over here. And now let's find another one that only has one unknown region. Again, you can almost always go bottom up in these list of numbers. We know that there's a total of 111 in regions 5 and 6, but we already know region 5. So we can calculate region 6 by taking that total of 111 and subtracting the 45 from region 5, which it looks like it's going to be 66. That's how many have to go in region 6. And again, if you just check real quick by temporarily getting rid of the T circle, the DR and DV circles, their overlap does add up to 111. All right, let's get rid of that highlighting. And let's cross out everywhere that has a 6. And again, you don't really have to do all this crossing out like I'm doing. But it does point out that as we move upwards, every time we move to the next number, there's only one unknown region. In this case, region 2. We know that 142, we're finding region 2 now. Region 2, is that the color I wanted? According to the highlighted number in yellow, there's 142 together in regions 2 and 5, but region 5 has 45. So if we subtract those, we get 97. Yes, which means there's 97 in region 2. Okay. Let's cross out everything that has a region 2. Now, if you look at the next 3 in our list, In their list of regions, each one only has one unknown region. So now we can just do a massive subtraction problem. For example, the 170 is the total of regions 4, 5, 6, and 7. 7 is the only one we don't know. So we can figure out region 7 by taking that 170 and subtracting the regions that we do know. Or think of it this way. The 170 represents the DV circle. The DV circle is here. All the numbers in there have to add up to 170. So all I have to do is take 170 and subtract the numbers that we already have. 46 plus 45 plus 66. And that will give us the missing piece of that circle. Calculator. Calculator. 170 minus 46 and 45 and 66 is 13, which means in region 7, we have just 13. Let's see if we can expedite the rest of these because this video is going on quite a bit. For the DR circle, it has to add up to 210. The DR circle is here. And so to figure out that missing region, which is region 3, for region 3, the total of that circle is 210. We subtract the sum of the ones that are already in there, which is the 97, the 45, and the 66. And let's see what we get. 210 minus 97 and 45 and 66. I got 2. Let me try that again a different way just to make sure I get the same answer. Yep, 2. There's only 2 people in this region. So there are only 2 people that were arrested for drugs only. I wonder if there's something you can infer from that. And then for the, not making a judgment call, just referring to the statistics. For the T circle, that has to add up to 194. And the T circle is right here. Since those have to add up to 194 and the only missing region is region 1, then we can do region 1 is 194 minus the sum of the numbers that are already in there. 97 plus 45 plus 46. And let's see what that would give us. 194 minus 97 and 45 and 46 gives us 6. Not a large number, but the number nonetheless. And there's only one region we haven't calculated yet. And we need to know the cardinality of region 8 to answer the last question. How many of the inmates were arrested for none of these 3 things? Well, how are we going to figure that out? Well, look at the very first number in the list. The very first number in the list, we'll highlight it in green. The 300 represents all 8 regions. And if you notice at this point, I have all but 1 region calculated. So to figure out region 8, I'll need to take the 300 and subtract all 7 numbers that are already in there. I don't want to do this on another page, so we'll just make some room over here. By the way, if you're in my class as a test question, I will ask you to write down how you got all of your numbers. So all the subtraction problems I have written, I am going to ask you to do when you take your test. All right. So for the last region, for region 8, that will be the total of 300, all 300 minus all 7 numbers we already have. So just going from regions 1 through 7, minus 6 plus 97 plus 2, hate having the line break there, plus 46 plus 45 plus 66 plus 13. Now there's actually 2 ways we can do this. We can add up all 7 of those numbers and then subtract it from 300, or we can subtract them individually. I'll subtract them individually. 300 minus 6, minus 97, minus 2, minus 46, minus 45, minus 66, minus 13 is 25, which means the number 25 goes in region 8 somewhere. So is it a lot of work to fill in the cardinalities of the regions? Actually, no, it's just a bunch of subtraction problems. The hard part is figuring out what to subtract from what. But if you can identify the number that represents a single region, and usually it's the guy in the middle, then you can work your way backwards and figure out all the other regions. I do want to make one more comment about a triple three-circle Venn diagram before we answer the questions. There are 3 circles in here which are fairly clear. Oops, that's not what I wanted. I had a nickel every time I said that. There's 3 circles in there. Circle, circle, circle. But there's also 3 what I call flower petals. Now in a 2-circle Venn diagram, I call them footballs. But here, because there's a middle, there's a flower petal here, made up of 2 regions. There's a flower petal here, made up of 2 regions, and there's a flower petal here, made up of 2 regions. But the middle of the flower is only 1 region. So the strategy for calculating the cardinalities, start with the middle because it's just 1 region. Find the numbers that represent each individual flower petal, because once you know the number in the middle, then you can figure out the missing number in each flower petal. Then by the time the middle and the flower petals are filled in, when you go to a circle, there's only 1 number missing because you know the flower petal's in the middle of the flower. And then by the time you get all 3 circles, you can figure out the last one. All right, let's answer all the questions pretty quickly because the questions are actually pretty easy to answer once you got the Venn diagram. All right, which ones were arrested for only drug offenses? Translation, what's the cardinality that's inside only the drug circle? The only number inside the drug circle is this one. Excuse me, the only number that's only inside the drug circle is that one. So the answer to that guy is 2. Next, theft and domestic violence, but not drug offenses. So in terms of circles, inside the T circle, inside the DV circle, outside the DR circle. There's only 1 region that is inside the T circle, and at the same time inside the DV circle, and at the same time outside of the DR circle. And that's this region. Region 4. That is the only region that is inside the T circle and inside the DV circle and outside the DR circle. And its cardinality is 46. T or D, we're on 3rd part here. Oops. Part C. Why is this doing this? There we go. We're on part C. How many arrested for theft or drug offenses, or possibly both, I believe it said. But that says or. Does or mean intersection or union? Or means union. So the union of the T and the DR circles. That would be here. So we have to do a little bit of math to figure out how many inmates are in there. We have to add up all the correct numbers, which would be 6 plus 97 plus 2 plus 46 plus 45 plus 66. I got 262, but I'm going to add them again in reverse, see if we get the same thing. 66 plus 45 plus 46 plus 2 plus 97 plus 6, 262. It really boils down to adding and or subtracting. None of these offenses, well, that one's pretty easy. If they were arrested for none of these offenses, they would not be in any of the circles. And what's the only number in the Venn diagram that's not in any of the circles? That one. So I wasn't kidding when I said answering the questions is really easy once you get the Venn diagram drawn. But in a 3-circle Venn diagram, the strategy is almost always, like I said already, find the number that represents the middle, Find the number that represents each of these flower petals. Then you just have to do a single subtraction problem to figure out the missing number in each petal. Then go for each circle, because at that point only one number is going to be missing from each circle. And then go for the outside.